Okay, so these notes are over solving logarithmic equations and inequalities. So we are going to solve log base 8 of x equals 4/3. So the easiest way to solve this logarithm, and we can't just put it in a calculator, is we're going to put it in exponential form. So putting this equation in exponential form, my base is 8. I'm raising it to the 4/3 power, and that equals x. We've talked about rational exponents before, so 8 raised to the 4/3 power means I'm taking the cube root of 8 and I'm raising that to the 4th power. So the cube root of 8 is 2, and then I'll be raising 2 to the 4th power. So I get that x is 16. So my answer is log base 8 of 16 equals 4/3. Next up, I have log base 27 of n equals 2/3. So I'm going to put it in exponential form. So my base is 27. It's raised to the 2/3 power, and that equals n. Raising 27 to the 2/3 power means I'm taking the cube root of 27, and I'm squaring that. So the cube root of 27 is 3, and now I square 3, so I get that n equals 9. Okay, this property of equality for logarithmic functions basically means if you have a log with a base set equal to another log with the same base, you can drop the logs, and whatever you're taking the log of, you can set equal to each other. So here, log base 5 of x equals log base 5 of 8. We're taking the log base 5 of both sides, so you can drop it and say that x equals 8. So I have log base 4 of x squared equals log base 4 of negative 6x minus 8. So since I have log base 4 on each side, I can drop it. So I get that x squared equals negative 6x minus 8. And now I can solve this. This is a quadratic, so I'm going to get everything over to the same side and see if I can factor it. So I'm going to add 6x, add 8. So I have x squared plus 6x plus 8 equals 0. And to factor it, I need factors of 8 that add up to 6, so that's 4 and 2. So my factors are x plus 4, x plus 2. So going into solving, I'll set each one equal to 0 and solve. So I get x equals negative 4. And x equals negative 2. Now, something you always have to check. Your logs can never be set equal. You can never take the log. You can never take the log of a negative number. So you have to double check that when you plug in whatever you get for x, that you're not ending up taking the log of a negative. So this right here can't be negative. So if I plug in negative 4, I'm doing negative 4 squared, which is positive 16. So that works out. And then if I plug in negative 4 here, negative 6 times negative 4 is 24. Minus 8 is a positive 16. So we're still good there. So negative 4 works. Now plugging in negative 2, we would have negative 2 squared, which is positive 4, so that's fine. And then negative 6 times negative 2 is positive 12, minus 8 is a positive 4, so that works too. So I have two solutions here. My two solutions are negative 4 and negative 2. So always double check that your answer, when you plug it in, you end up taking the log of a positive number, or you can even So I have log base 4 of x squared equals log base 4 of x plus 20. So I can go ahead and drop the log since I'm taking log base 4 of each. So I get x squared equals x plus 20. So this is a quadratic, so I'm just going to move everything over to one side. So I get x squared minus x minus 20 equals 0. And now I'm going to factor. So factors of negative 20 that add up to negative 1 are negative 5 and positive 4. So not x squared. Let me erase that. X minus 5 and x plus 4 equals 0. So I get that x equals positive 5 and x equals negative 4. And plug that into check. So 5 squared is 25, so that's good. And then 5 plus 20 is 25, so that's good. So 5 is good. And then plugging in negative 4. Negative 4 squared is 16, so that's good. And then negative 4 plus 20 is positive 16, so that's good. So both work. So 5 and negative 4 are my solutions. And that is it for solving logarithmic equations and inequalities for today.